This is Module 1, Topic A, Lesson 3. Our objective is to use exponents to name place value units and explain patterns in the placement of the decimal point. So, let's look at a problem. We have 10 times blank equals 10. What would we put in to solve this problem? What would go in the blank? Well, 1 would go in the blank. So we're going to put 10 up at the top of our chart, and we're going to write 10 times 1 right underneath it. Here's another one. 10 times blank equals 100. What would go in the blank? Well, 10 times 10 equals 100. We're going to put 100 up next to the 10. And then right under it, we're going to do 10 times 10. Now, using only 10 as a factor, we can multiply to get 1,000. And we would do that by 10 times 10 times 10 equals 1,000. Okay, and we're going to put 1,000 up there. And underneath it, we're going to do 10 times 10 times 10. Well, what if we wanted to use only 10 as a factor to get 10,000? That would be 10 times 10 times 10 times 10 equals 10,000. We're going to add that up on our chart as well. So how many zeros are in our product of 10,000? Well, you'll notice that there are 4 zeros in 10,000. So there are some patterns that we should be noticing. And some of them are, the number of zeros is the same on both sides of the equation. 10 times 10 times 10 times 10 has 4 zeros, and 10,000 has 4 zeros. We could say this, the number of zeros in the product, or the answer, is the same as the total number of zeros in the factors. We could look at it this way, the 1 moves 1 place to the left every time we multiply by 10. Moves 1 place to the left and we add another 0. Or you could finally look at it, each number is 10 times as much as the last one. So, going back to our chart. So we're going to keep going and say that 10 times 10 times 10 times 10 times 10 equals 100,000. If you notice, those 10s have 5 zeros altogether, and 100,000 has 5 zeros. We're also going to say 10 times 10 times 10 times 10 times 10 times 10 equals 1 million. Again, the 10s altogether have 6 zeros. 1 million has 6 zeros. And we're going to go ahead and add those up to our chart as well. Okay, so now let's look at what exponents are. We can use an exponent to represent how many times we use 10 as a factor. So we can write 10 times 10 as 10 to the second power. The 2 is the exponent, and it tells us how many times to use 10 as a factor. Twice, 2 times 10 times 10. We're going to add that to our chart. So we have 10 times 1 would be 10 to the first power. 10 times 10 would be 10 to the second power, because we have 2 10s as our factor. 1,000, or 10 times 10 times 10, would be 10 to the third power. 10,000, or 10 times 10 times 10 times 10, would be 10 to the fourth power. 100,000, or 10 times 10 times 10 times 10 times 10, would be 10 to the fifth power. And 1 million, which is 10 times 10 times 10 times 10 times 10 times 10, would be 10 to the sixth power. So you notice we have the exponent represents the numbers of 10s that we multiply together. So a googol, if we multiply 10 100 times, we can write it like this, 10 to the 100th power. This is also called a googol. So it works all the way up. So let's expand on this by doing something new. So here we have 3 times 10 to the second power. The first thing I want us to do is think about how can we write 3 times 10 to the second power without the exponent? Well, we would keep the 3 the same, and 10 to the second power is 100. So we can write it as 3 times 100. What's the product or the answer of 3 times 100? Well, that's 300. So you can say that if you know that 3 times 100 equals 300, then you know that 3 times 10 to the second power equals 300. Now let's see how that works with division. Here we have 700 divided by 10 to the second power. The first thing we're going to do again is write 700 divided by 10 to the second power without exponents and find the quotient. So that gives us 700 divided by 100 equals 7. Remember, 10 to the second power is 10 times 10. That's 100. So going further, if you know that 700 divided by 100 equals 7, then you also know that 700 divided by 10 to the second power equals 7. We're going to look at more problems like this in class tomorrow.